In this tutorial we are going to represent an automatic irrigation system. The first thing to do is identify which components are in our system. What is proposed is that these components are classified within a 3-tier IoT architecture model. Once we have our devices, the next step is to classify these devices. On the left side we have a library of elements that we can drag and add these elements. We can go to this section and search for example wireless sensors, wired sensors. For example, if we consider the water pump, we would navigate to the section that deals with actuators, and there we would find the representation for the pump. Then, we have a Wi-Fi relay which is an actuator, and it's Wi-Fi, it's wireless. And so we'll go to the wireless actors section and we would look for the corresponding element, and all we would do is drag them to the work area. Well, here as we can see, we already have more elements added, which we have extracted of this section. We have the humidity sensors, temperature and brightness. It is worth mentioning that the shape or outline of each of these elements indicates the type of element in question. These elements are formed when we have, for example, an outline for a sensor and we add an icon from an icon family to it. There is a table that contains all these icons for different sensors, and with this we can specify that it is a luminosity sensor, and so on for each of the elements. Here we have one of luminosity, one of temperature and one of humidity. We have already added these elements in this part. We got the pump component and we have the electrical relay component. How can you observe these elements have aggregates to outline these little indicators? What the element is going to indicate in this case is the type of communication with which this sensor, this device, communicates with the other's elements. There are 3 forms of communication that were considered, are shown here. It is the wireless communication, by this symbol, that is to say the communication through the air. Wired communication, when it is through a cable, it can be a protocol that can be 32 rupees or it can be Ethernet, or also this element is used for analog connections, that is, those that transmit a voltage intensity, only. This type of communication is what we have here. We have an Arduino card and has a sensor directly connected to one of its digital outputs, then it is an analog type connection and is wired. The case of the unknown connection, this is used when defining what the cloud platform is. We already have the sensor elements, the relay, and the pump in place. What's still needed are the Arduino card and the access point. This last element is classified as an edge component, as it represents the edge of the local system that's already connected to the internet. These elements are categorized within the section labeled as edge. As for the cloud platform, which constitutes the uppermost layer in our layered model, we will address that in the subsequent steps. Between the cloud layer and the network layer, we'll have the portion corresponding to the internet. To denote the presence or passage over the internet in this layer, we introduce a virtual element. This virtual item is depicted as a circle, symbolizing the entire internet network. It represents the information traveling from our system through the access point to the cloud service platform. However, we are going to have components within our system that serve multiple functions. These components, which we consider multifunctional elements, are represented in a very specific manner. We'll employ an auxiliary element known as the core, which acts as the heart of the IoT device. This core serves to group together various sensors, actuators, etc., that are part of a multifunctional element. By connecting these components to the core, we convey that they constitute a single physical device with integrated sensors, actuators, and even a communication gateway. To create such elements, we start by recognizing that the Arduino board, as shown in the image, is linked to both analog sensors. In this sense, the Arduino board itself can be regarded as a multifunctional device, as it contains diverse components performing distinct tasks. In our design environment, we would search for the device core among the virtual elements. In this instance, the Arduino is equipped with a Wi-Fi card and is capable of wireless communication. Thus, we select a wireless core device and indicate its wireless communication capability. We then proceed to connect components analogously linked to the core, specifically, the temperature, humidity, and luminosity sensors. To establish a connection within our design, we simply drag and position the arrow to join the devices. To denote the multifunctional nature of the element, we can include a container. This rectangular element is dragged and positioned to envelop the entire multifunctional device. By placing the rectangle behind other elements, we complete our IoT multifunction device representation. The underlying concept is to streamline the diagram. This composite element encompasses the temperature sensor, luminosity sensor, Arduino board, and the communication module, enabling wireless communication for the Arduino board. Ultimately, The communication module is depicted as a single element, the wireless communication terminal. Now, let's move on to the boundary elements. As previously mentioned, systems require a way to connect to the internet. These connection points are edge devices, which could be a Wi-Fi access point, a modem, or even a cellular data access point. In our case, the edge device will be a Wi-Fi internet access point that communicates with the Arduino board. Remember that this Arduino board is linked with sensors and a communication module. Once we have the edge device established, the subsequent element in the sequence is the internet element. This indicates a connection over an internet network has been established. Once the internet element is in place, along with the necessary edge device for an IoT system and the perception layer elements, the next step is to establish the cloud platform. For this purpose, we require two essential elements. Firstly, a virtual element known as the cloud core is necessary, which represents the entire cloud platform. This platform offers various services such as data storage and processing. Second, services. These services are structured as cloud functions, as depicted here, to specify the utilization of a particular service in the cloud within our IoT system. We connect the relevant cloud functions to this cloud core element. By doing so, we signify that our cloud platform provides and supports these services, which can be accessed through our IoT system. Subsequently, we need to connect the cloud platform to the internet element to signify that it's accessible via the internet. Now, the remaining step is to establish the remaining connections within the diagram. With the communication components in place, the diagram would look somewhat like this. Each communication line could be annotated with the type of communication protocol, such as Wi-Fi or Ethernet. Within our system, users have the ability to visualize plant-related data via their mobile phones. To represent this, we need to add a visual element that signifies the user. The user is situated here, as this element, and they would connect through a mobile phone. We can conceptualize the phone as a multifunctional element, similar to what we did with the Arduino board using the device core element. The user interacts with the phone using a touch sensor. In the sensors section, we can identify a touch sensor, since it's integrated within the phone and connected via a bus. We would need to include the appropriate connections. In addition to the touch sensor, the phone also features a screen, which acts as an actuator. Moving to the actuator part, we would look for a screen element that corresponds to a wired connection. The screen interacts with the user, serving as the medium through which information is viewed. To indicate that the user interacts with these elements, a simple line, like the typical black lines representing communication, wouldn't be appropriate. Instead, a dotted line would be used. In this context, a dotted line represents interaction within the IoT system. For instance, consider the interaction between a sensor and an object. A sensor might measure the temperature of an oven. To represent this interaction, you can apply a dotted line style. This visually signifies that there is an interaction taking place. This distinction is crucial in IoT systems. Given their combination of cyber and physical elements, the phone device can connect through cellular data communication, such as telephone networks. To depict this, you would search for the appropriate element and connect it wirelessly using the relevant protocol. For connections reaching the cloud, you would include another element representing the internet. This would be the general structure of the diagram. However, each element must be positioned accordingly. The cloud element should be higher up to denote the internet layer. The edge device should be positioned here to represent its role as a border access element, and the user element should be placed within the perception layer. In cases where you have a fog-type device, which performs cloud-like functions locally, you'd need to modify the representation. To signify it's a fog device, you'd replace the device core with a fog core. Additionally, if the fog device performs certain data processing tasks, for example, data transformation, you can depict this by adding a cloud function. Treat the cloud function similarly to how you would connect a sensor to an actuator. And this would complete your representation of a fog device. Please note that diagram layout and placement are essential for clear communication and understanding of the IoT system's structure and interactions. Thank you for watching this video tutorial of ViLanIoT. If you have any more questions or need assistance in the future, don't hesitate to ask. Good luck with creating your IoT diagrams.